with this, we are going to start off with the next session. I hope everyone has had a good meal. And before we all start feeling like napping, we want to make sure that the energy is back up again. And I have a very special speaker to invite in next. Now I would like to invite a brilliant mind in mathematics and computer science, who is currently leading the Center for Developing Intelligent Systems at IIT Kanpur. He's known for his 15 plus years of research and algorithms and pioneering an AKS primality test, previously taught at institutions like Bonn University. Let's give a warm welcome to Professor Nitin Saxena.
Giving me the stage. I'm not used to coming to corporate events, so this is my first one. Yeah, yesterday actually I attended a panel discussion here where a very sage advice was given by somebody, I forget the name. So he said that, we should be focusing on problems and best solutions and not tech. Okay, it is not that we should be obsessed with a particular technology and which is fashionable now, may not be fashionable tomorrow, or it may not be fashionable today, it may become fashionable tomorrow and so on. But we should be focused only on solving the problem and then bringing it to a bigger scale. Our focus should be that. So he said that we should be using just common sense and we should be starting from first principles. So now my center here with Nishit CDS, we take this sage advice to heart. Okay, so I will show you not the tech part, but I'll show you the use cases, the problem statements that were given to us by clients, and we solve them, and we try to bring it up to scale. And you are free to interrupt me. I have many slides and very little time. So I'll prefer if you ask questions and we don't finish the slides. So since this is the AI session, so I have to talk about AI. So I'll basically divide in three parts, the use cases, sensing, deciding, and acting. So I'll show you the examples. So AI for sensing, so for example, you may have IoT-based sensing of environmental parameters, which can be, these days it can be pollution, pollution in air, it can be pollution in rivers, it can be presence of waste which shouldn't be there on the streets. So they are sensed, but sensing is easy for human beings. It is very hard for machines. So sensing is a complicated process, and generally there is no set algorithm for it. So you actually use AI. You have to train the system to understand that this is fresh air and this air is polluted. So AI goes into that also. There is second example is basically taking UAV photographs or using drones. You take pictures, and then again those pictures the machines cannot. We can immediately see that there is a land parcel or there is a boundary, but the machine, you want an image processing algorithm to actually detect that, and that detection again is based on AI. There is no set algorithm because the land is complicated. Even the color green, for example, distinguishing green from brown, what we see with our eyes, it may not be so easy for the machine. So this is the best way is these days to just use DL or ML algorithms for that. So you have to train it. So that's land parcel detection, or in fact boundaries first. Third example is movement of traffic. You have CCTV footage and you want to sense traffic. Similar thing is, we are also doing it for the highways. We haven't completely implemented, but they have the use case. So when the highway authority builds highways, they have to cut trees. So for example, they want to count the trees. So how many trees were cut, and then they have to replenish that somewhere else or there. So that again is not very trivial. We can see the trees, but obviously in a photograph of probably low resolution on a big scale, you have to train a system which actually counts trees. So we had some master students who did this as a thesis, and it was not bad. So using that, you can actually count. You can first of all, you can detect trees. That itself is a AI problem. Fourth is similar thing, movement of cargo, be it air or sea. and digitization of paper-based documents. So we talk a lot with these government agencies, for example, police or land records, and their systems are generally, and especially for the police, their systems are British-era systems. They are very outdated. They don't even have a way so that the hundreds of police stations or offices can read what is written on a paper and scanned. It is in Hindi or in Kannada or whatever, and it has to be first translated. I mean, ideally you want to digitize means that you want to translate it, you want to put it in English, and then it should be searchable. So that whole pipeline they have not built. Probably they haven't even thought about it. So that is the document sensing part. It's technically a solved problem. I mean, in your Adobe PDF, you can ask it to find text in image. So that's the OCR technology. But this has not penetrated to the masses in India. So we talk about a lot of fancy things, but even the basic things are not really implemented at the local government level. Okay, so this is a problem we try to solve for them. And finally, the biggest thing, the last but the biggest thing is something which the Prime Minister himself now uses. So over the years, we have developed a system. It's basically Nishit's project. He started with very small money, and then the Prime Minister liked it. It started with Ministry of Defense, and then Prime Minister demanded that all the ministries should use it now. So it is now present in all the ministries. It's a back-end system. So when you go to PM Grievances portal, you will not see it. You will just see this NIC-based form. But so that form collects complaints about all aspects of government in the country. The problem is that how to take action, because people who complain, they basically rant. So they may not even be aware of what they are ranting about, which department this complaint should go. So there will be a long rant probably present in a PDF. It may even be handwritten in Hindi and then scanned and uploaded. So there are these, again, OCR issues, but let's remove the OCR issues. So finally, the text itself, when you have as English sentences, the problem is that an officer has to read that in the back end and understand that which department it pertains to, so that he can send it to that department. And this is a very difficult problem, because attached to when it reads a sentence, it will attach a bag of meaningful words, which may not even be present in the sentence. Like, so for example, I went to this office and I wanted to register my property, but they charged me 1,000 rupees. Now, corruption word is not there, but it is corruption related to land record office. So this will now be understood by AI. So these bag of words will be attached to this sentence or to this PDF. And so categorization happens using semantic search and some language model. So once you have done this, so now you have categories, and one complaint may be present in many categories, so it can be now sent to those departments automatically. So instead of the officers pulling complaints, now this is being pushed, right? So the AI system is now actually understanding it, and it is pushing to the relevant departments. And the officers also, I mean, now over the years, our dashboard has evolved a lot. So now officer can write some random sentence in the search box, and the geographical distribution of complaints related to that sentence is shown. So I'll show you some pictures now. So we call it discovering intent. Okay, so citizen means this, but he or she has not written it, and the machine learns the intent, pushes the complaint with the intent. So this is one of the favorite of the Prime Minister himself. How do I move forward in life? Okay, a bit slowly. So this is the picture for land parcel detection. So this is the first job. You have these pictures, but the colored rectangles or polygons are not there. So this is drawn by image processing software, which is, I think it is not very expensive, so it's probably even present in the drone itself. You can upload it in the drone. So it sees these things and then it colors them. So you can see that there will be some errors, like in the rightmost edge, there is a non-polygon object. And this is happening because of the trees there, and the color is then too complex. So it's not very easy where the land is beginning and where it is ending. But mostly it is correct. Mostly you can see the squares and the rectangles and the quadrilaterals and the trapeziums and all that. Yeah, so that is the detection in land photographs taken from drone. We have this almost, this POC has been shown to UP government, and most probably we'll get this project. So then it will be used for mainly rural land digitization of their data records. Because there is a drone company which can do that. It has drones, it goes and takes photographs. Second is this big project that is deployed already. So it is deployed for all central government departments and ministries, and many other state governments are also interested. Just somebody from Gujarat Chief Minister Office visited, and Haryana Chief Minister also we talked to, and many others. It's always difficult to understand when we talk to them whether it will actually get deployed. So talking is one thing, doing is something else. There is always a gap, but at least people are getting aware. So the complaints in old-fashioned style on the portal are entered by the citizens. Then there is an AI engine which will identify the gist, identify the intent, even if it is not present. Those keywords are not present. It is not Google. It's more than Google. So it's like you write down your feelings, and then Google will give you text corresponding to that feeling without using the same keywords. Right? So it's about semantic search. So like officials asking for bribes to issue certificates, you click on that. The officer will click on the box in the back end, and there will be a list of such complaints or grievances retrieved and listed. The third example is detecting structure within documents. So this is again a project which is with several agencies. This I think is to probably with the it's an example, but ultimately it is being used to read insurance claim forms. So the form will have basically the person submits insurance claim listing the medicine names, and then it is scanned and uploaded. And so what is the medicine name and what is the claim for? These two things have to be matched approximately. And if there is a big concern, then it is flagged and manually checked. Right? So for that, you have to identify the red parts are the fixed keywords, the fields, and the green parts are the input which was given by the shop or the shopkeeper or the patient who bought the medicines and so on. And so that is now so the first one is slightly easier. The second one is more complicated, as you can see, because there are also those thumbprints and signatures, etc., and that confuses the system. So the data which is available around the thumbprint will again be messy. So obviously some manual intervention will be needed, and there will be some mistakes, but largely it works. So this is sensing structure within documents. Now we can move to decision after sense. So once you have sensed some structure, you have to make a decision. So what is the decision? So in the land parcel example, the decision is that you have multiple trapezia or quadrilaterals, and you want to combine them, saying that all these quadrilaterals belong to person X. There is some villager X. All this land is for person X. Because in India, the lands are not like the West. They are not neat rectangles. They can be any figure. And over time, they get fragmented. So a rectangle will be divided into smaller trapezia, each one going to a brother, and so on. Right? So the figures ultimately are very complicated. So you have to combine, you are triangularizing, and then you are assigning a name to a big area. So that is the consolidation part. But already the things have been digitized since you had the rectangle. So after digitization, it's a standard algorithm. Then you don't need AI. AI was needed only for the sensing part. The decision part here is, I think it is AI free. We don't use AI anymore. Now you can actually look at the graph and you just use a graph algorithm. But the second one definitely needs AI. So this is once you have identified the document structure or the information present in the form, and then you have digitized it, you have to detect whether there is a fraud. Now fraud is a very nebulous thing. It can be fraud for you, but not for me. So this is an AI decision. So the basic over the years, like several business rules have been added into the system. So now there are some 50 plus rules. So based on those rules, and some of those rules are not easy to learn. So for that you have to use AI models you have to build. And ultimately there is an answer whether after all these forms and patient records, doctor records, whether there was a fraud committed in the insurance, health insurance. And believe it or not, this has been saving tens of crores to National Health Authority. It comes every few months in the news. I mean, they don't credit IIT Kanpur because they say that they have developed it. And this is always a good sign. I mean, if you develop something and other people claim it's theirs, it means that the product is useful. And when the product is useless, they say that, well, IIT Kanpur is the inventor of it. So we considered it as a very good thing that they don't credit us. But this actually is built and maintained by us in the center. And the main mind behind this is actually Nitin Saxena. So he has been doing this for multiple years, and now it's, I hear that it will soon be a case study in MIT Sloan Management School. So you can read there. Third is, which we have proposed to UP Police, that do police investigation not in the British style, which is 100 years old, but maybe make it slightly more intelligent, if not artificially intelligent, at least basic intelligence, using basic algorithms, which is network analysis. Maybe I'll have an image about that in the next slides. Fourth is pollution source apportionment. So what is this? So in Delhi, you see every year people are choking to death because of so much of pollution, and the government says we don't know why the pollution is there. It may be because the people eat meat and beef, because of that there is pollution. I don't know. So you want to find the reason, right? Whether it is because of eating beef, or because of somebody burning lands, or because it is cars and traffic and whatnot. So you have to assign the blame. And that is our inherently AI problem, because even to detect that there is pollution, it's an AI problem. But for that, I believe the models are very good. The sensors measure the air, whatever the air chemistry, and then there is a model which decides whether this chemistry suggests presence of pollutants and this small matter which should not have been present. But then the last thing is the hardest, which is you have to assign blame. Where did it come from? Right? So there you make even more mistakes. So we have a faculty, Purushottam Kar, who works with civil engineering experts and with Delhi government. He has worked with actual data. It may be from various places, where they try to assign the blame that, okay, 10% is because of this, 20%, 30%, and so on. And that is also a published, there are published articles on that. So you have to use both chemistry and AI. And obviously real data, and you should have already labels. You should know that when land burns, what is added in the air. And when a car like stage Bharat 2 or Bharat 3 or Bharat 4, what are the different pollutants which are added? You have to assign the blame that way. Yeah, and the fifth one is this decision making in the grievances example. So once you have attached the bag of, once you have categorized or classified the grievance, you want to find the possible root cause of so many complaints that the government is getting. Right? What is the root cause? So the root cause analysis is done. The output of that is again a bag of words. It will tell you, or it will suggest to the officer a bigger reason for this problem. Okay. Based on, again, training. Over the months, so many complaints have come. Why have they come? Maybe there is a particular officer in office who is causing this problem, or maybe simply the policies are wrong. Yeah, so this is the picture for land consolidation. These, you have to make it, you have to assign people to each of these rectangles and then join them. And yeah, root cause analysis is automated detection of important topics in these grievances. And the output is, for example, each of these rows show you a bunch of a bag of words from which it's not very hard actually. If you read this as a human being, it's not very hard to understand what is the reason for complaints, and then you can take a majority vote and you can find that most probably this is one reason why so many complaints have come this month. So most importantly, I mean, this is AI is just a tool, right? It's a slave that you should use. Ultimately, you should change the system itself, the governmental system. So last point is about that once you know after the root cause analysis what is the root cause, what is the possible cause, you should be doing process re-engineering, which is that the government should go back and actually correct those problems physically in person in that office or in that policy, right? This is, I mean, we will not go very far with AI. We have to ultimately change people and change systems. So that also is a major part which is going on. So then the IS officers or the secretaries or even the ministers, they then say that, okay, this is a big problem, you change the process in the office. So yeah, so this is another picture. So first, so you can just type MN Rega, press search, so it will show where the MN Rega complaints came from. But this is, the second one is more interesting because you have a meaningful sentence. And then you see that the bubbles are now bigger, right? So that is collecting the semantics. Semantic search is collecting many more things than a specific keyword, right? So, and that shows that there is a systemic problem. It shows that Indians are corrupt and the systems are old-fashioned. So you have to do process engineering, change that. Okay. Yeah, but my pointer doesn't have AI, so I keep getting stuck. Okay, so this is these are the 50 plus, I mean, I'm not showing you the rules, but some of the categories of the rules. So there are more than 50 plus rules. This is done with collaboration with Ernst & Young because they have the contract for this insurance fraud detection from NHA. So there are rules based on doctor's advice. So those are clinical based rules. Basically, if somebody is claiming a disease, but that disease only happens to old people, then a 10-year-old should not have that disease with high probability, right? So those are the kind of basic rules, which is basic logic or algorithmic idea. Then there are more complicated rules for which you will have to model. So that is the ML part. So you can do statistical detection. I mean, you can use statistical methods, or you can use more fancy MLDL models. And yeah, so you can assign risk scores for a disease for a particular person, and if the score is very low, then most probably it's a fraud. Obviously, I mean, this will not stand in code, so it has to be then flagged and somebody manually checks it. But you can see that this will reduce the job a lot because they submit a lot of documents, and if we can reduce the amount of documents which are to be read by a human being, it increases their efficiency. They will be more careful to read. Okay. The next example is, yeah. So this is proposed for policing and especially in anti-corruption investigations. So the person in the center, the red people, they are known. The police case is against them, and network analysis will basically look at the data which is available, which we are proposing should be the call data record, who this person calls to, because with the call you can also find out, you can match it with UPI transactions, right? So you will not catch just one person, you will catch hundreds of people, because usually when you do corruption, you don't keep the money with you. You try to spread it out to your family. You don't like friends very much because friends may complain against you, but family is the best. If you are corrupt, distribute in your family. So you want to identify that who are the family members to whom calls were made and then money transactions done. So this acquaintance network, and this, by the way, is an example, actual example from Swedish street gang analysis. I just picked it off Wikipedia. But this exactly is the idea. So you find, so police can actually, I mean, I don't know whether they will implement it, but if they implement it ever, they will have better reports for the judge, okay? Because they can actually show that, look, these are the calls made. This is the UPI transaction ultimately made, bank transaction done. and this is how the money is flowing, right? So that is better investigation. Right now, they just do it manually. They just try to guess whether this person is close to that person, and then this is all very shady. It's not proven. There is no hardcore evidence. But with everything being done on UPI or online, now you can actually do the network analysis and find evidence. So the green people are closer in the circle, the blue ones are further away, and you can find witnesses there and so on. So this will furnish exhaustive evidence if implemented in charge sheets and reports. And finally, the AI for acting. So this is, obviously the IoT systems, once you have sensed and decided, then you can also act. So you can send emergency like ambulance or police vehicles or petrol vehicles and so on. So auto responders can be sent, and finally there could be an automated compliance system. So for example, the point where the grievance is being submitted or the point where the insurance form is being submitted, at that point itself it can be flagged. So the citizen has the opportunity to change, right? So there is the AI system is actually pointing out the errors right there. So it doesn't even go into fraud. So this is an example. This was field tested, verified, validated in Kanpur city with the UP police when there was a friendly DIG or IG, and when he was transferred, then the system collapsed. So it is not functional right now. But when it was functional, it was saving the response time and also fuel consumption of the petrol vehicles. So these petrol vehicles are currently just manually assigned. So instead of that, you can assign them according to the distribution of crime. So last 2-3 months, you can look at the data and then assign according to, vehicle can be placed closer to a place where the probability of crime is higher. Right? It's a simple thing. But since the city can be big, and for example, Bangalore is multiple cities, so there you can't just do this manually. You want a system that looks at the exhaustive data, does some statistical analysis, finds clusters, and then places the vehicles in these clusters. So that anywhere in the vicinity, when people make a call, the call from the control room will go to the petrol vehicle, and then the petrol vehicle goes to the... Okay. Yeah, so I'm not very efficient here. I'm not saving your time. But this one will, if you implement. Okay. And similar idea we are using for allocating engineers. It's a company here based in Bangalore. They have given us a small project. So we are trying to do the same thing in a different situation. But idea is the same. It's both statistical analysis and some part of RL, which is reinforcement learning. There is some AI in this. And finally, there is a big state which has given us, it has been 2 years, they gave us a project where they gave us data that they have of all their citizens. And with that data, we have designed an AI system which predicts income or estimates income. It's an income estimation project. So once you have estimated income, you can potentially, the government can target, they can do welfare in a targeted way. So they can include people who were previously not included, and they can exclude people who were previously included. Right? There are many rich people, you ask them in the survey what is their income, and they will give you only 10% of the value, so they are getting welfare. So you want to exclude, but more importantly, you want to include. So we have salary labels for the people who are employed, and from that, we can look at the other parameters like electricity bill. So there is a cube that should draw here. Yeah. So you can, there are 15 parameters, but the most important ones which actually give us results are only these 3. Electricity bill, what place, what school the children of the family go to, and third is what kind of vehicles are there. And so this, with looking at the actual salary labels, you can create a model which then you can apply on people who don't have salary. Right? So you can estimate their income. And this is, by the way, mostly statistical analysis. This is not even AI as people in this conference understand it, because AI these days is something which you don't understand. As soon as you understand, you will not call it AI, right? So that is the dictum that society follows, and this we understand, so we don't call this AI. But if we didn't understand it, if there was no explanation, then it's AI. So this is what has happened. Previous panelists were also wondering why there was a time when 1956 AI was there, but then that was forgotten, and what happened in the 80s. So what happens is that as soon as you understand algorithms, you stop calling them AI. Then something ununderstandable, unexplainable becomes AI, and this keeps changing. So it's a very nebulous term. It is good to use it because politicians and managers immediately get excited. So if I said that I'm using statistics and algebra, well, who cares? This is the European Enlightenment. We don't want it here. But if I say that, well, we'll use AI, they're excited. So this is a very good thing, and I encourage all the startups to use this. They have encouraged me to use it actually. So we use multivariate regression modeling to predict income. They want us to use more parameters, but the coverage is very little. So the biggest coverage is in the electricity bill, because every house has digital bills. So that is the easiest, which covers all the citizens. As you move to other databases, the coverage is smaller. I won't name the state, but this is an advanced state, so they have still better systems. For example, if it was a state of UP or Bihar, this will be even worse. But even in the best states, the data collection and storage, it is not nice. So the data is very, very ugly, and there are a lot of mistakes. You don't even know whether the name of the person is correct, because it will be written in 1,000 ways. Amit may have tons of spelling, so you don't know what Amit Kumar it is. So all that also requires some statistical analysis to give a probability that whether it's the correct Amit Kumar or not. So there is some data cleanup. In fact, most of the part is cleaning up the data. You have to clean it up, then you create the model. And then it has to be ultimately validated. So validation, we have created better surveys. So we can identify 1,000 homes, and they can go to those random 1,000 homes and check whether what we are saying is correct or not, or whether they believe it is correct or not. Because in this business, you will make a lot of mistakes, because income is not a well-defined thing. Income is like AI. It's not something you understand. So, and the chief minister wants us to give him a number. Now that makes it very difficult, because when you don't even know what income is as a concept, how can you assign a number to it? So we make mistakes, but at least this gives, since it is based on correct parameters, it gives you some idea about, okay, this is how two people compare. One should get the welfare, other should not get. So I think at this point I can stop. You can ask questions. I can just go to, so this was about what are the problems in AI, and how do you, if you want to apply AI methods in your company, then how do you verify, how do you assess the risk, right? So assessing the risk is a problem. So there are managerial systems or policies being built around this. The standards are not yet there, but the standards have to focus on what is the biggest risk that your system has, and what is it that it is mostly intended to do, and assign probabilities, hopefully. But again, it will be case by case. You cannot say that in all cases it will be good. You can only say that in this case it's good, in that case it's bad. So it's a title recommendation. So the AI is a weapon of math destruction. If you are interested, you can read this book.
We'll open for questions, Nitin.
This is very slow. I wanted to skip and get to maybe just one more slide. Can I reach the end quickly? Probably not. You are forced to read everything. Well, anyways, I think I should maybe just stop here then.
It reminds me of my one-on-one. 101.
ESC 101. Okay. So thank you.
And Nitin will be here with us. Professor Nitin will be with us. So please feel free to ask him, catch him outside also. So I would like to take questions from back. Anyone has? Okay.
Presentation was excellent. Being a professor in mathematics and the subject on AI, It was exemplary, I would say. I'm also a professor, Paul Dayanathy. My AI on deciding for public grievances. If the data is wrong, then your prediction is wrong, no? See, for example, because AI is based on data, what you have for the old data. For the grievances, if the data is wrong, because you can see so many wrong things are happened by the police and all this stuff. So if the data itself is wrong, then the AI will give a wrong prediction of the grievance committed by a person, and a wrong person will be caught for a thing which he has not done.
No,
Am I
but,
right or not?
But grievance portal is, it may not lead to an arrest.
Yeah,
or even a court case.
but I
so this
think
is more about what the citizens, if some citizens feel that there is corruption in this office, I mean, somebody has to take care of that.
Even for
Otherwise,
example,
they will start a revolution. There will be a French revolution and politicians will be killed.
even
So to
of
stop that, some
Yeah.
redressal has to be done.
Yeah. So because AI for public grievances like criminal violences and all, it will be a pretty big. I think AI will not be suitable.
No, but see, this ultimately, as I said, ultimately this will be manually checked. Currently the Supreme Court, I think, Supreme Court has the number of cases is so large, pending cases, that to manually check these, it will take 300 years. So how do you reduce 300 years of Supreme Court judgments to 3 years? You have to do something. You have to somehow send it through an AI process which classifies it into the most serious cases, less serious and trivial or fraud or fake cases.
Okay, so we'll be able to take only one question for the day, but I have to thank you, Professor Nitin, a lot. I think it was a very information-rich slides for us. We had a lot of insights, especially from all the public challenges that we face, whether that be in land as well as on traffic and so on. So I'm really glad we had this opportunity to hear him out. And I was thinking we have a trolley problem. You remember the classic trolley problem, right? So on one track, we have a time constraint of keeping the event on track. On the other hand, we have wonderful knowledge that is being shared right now. So we were all walking that thin line, and I'm really glad that we could spend more time. Thank you so much, Professor.